Are you an undergraduate student who is pursuing engineering mathematics in any of the institution? Or are you an engineer who is really struggling too much on understanding engineering or scientific mathematics? Or are you a parent who have a son or a daughter who is pursuing engineering programs in any of the institutions around the world or in any of the institutions in Tanzania? So you've been looking at an online school that can help you more hard to understand engineering and scientific mathematics. Or are you a undergraduate first-year student who has been struggling on understanding Fourier series? So you've been looking at an online help. And I would like to tell you in advance the answer of all those questions that I've mentioned, and even the other one I didn't mention, will be revealed in this session, so I ask you to stay tuned. How are you, everybody who is watching this fantastic program? My name is Olenjolai. I thank God by His own grace who have made me to be an international teacher. And I thank God who have given me a gift of teaching, so I will be teaching you the beauty of higher engineering and scientific mathematics. I am a Tanzanian, that's my nationality, and this is our national flag. But I thank God also who have made me to be a citizen of the kingdoms of heaven. So I'm also a citizen of the kingdom of heaven. So I would like to take this moment to welcome all our online students into this fantastic moment. And because we really honor God in our online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, and we really need God in teaching, we really need God in understanding what we are teaching. So I would like to join your faith, I would like to join together with you by faith, just having a prayer of 1 minute in order to invite God to take part into this fantastic moment before I just give you some information that will help you to go through. So let us pray. Our Father who is in heaven, we come before your presence. We thank you for your greatness. Thank you because you're wonderful. You're grateful. Myself, as a teacher of these programs, and you are the head teacher, you're the great teacher, Father. I would like to join with all our online students in order to come before your presence, in order to invite your presence to teach us and help us to understand problem solving of Fourier series of the periodic functions of the 2 of pi. Father, we repent, we confess for all our sins, our transgression, our iniquities, and right now we come before your presence. We ask you to be in charge of this fantastic moment. Bless every online student and distribute these contents in Jesus' name. Amen. Thank you very much. I would like to take this opportunity to welcome all our online students into our fantastic online institution that's called the Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. And simultaneously, I'll take this opportunity to welcome all our online students also onto one of our official YouTube channel that's called Online Undergrad Institute of Tanzania in square bracket OLENJOLAIM. So with this fantastic moment, we'll be enjoying the beauty of engineering and scientific mathematics. I would like to welcome you into the departments of higher engineering and scientific mathematics, where we'll be enjoying the beauty of scientific mathematics and the beauty of higher engineering mathematics. I thank God also by His own grace, I'm electronic and telecommunication engineer by profession. But it's only by God's grace. So what am I teaching you is what I used it to learn myself, and what also I like it to learn every day. Do you love engineering mathematics? Tell me in the comment sections below. So we are dedicating these contents to our first year BEng. This is the abbreviation of Bachelor in Engineering, and the Bachelor in Science, BSc, it is Bachelor in Science, or NT Level 7 for the NAT educational system in Tanzania. We are in Chapter 5 that called Fourier series, and this is Session 5 that called problem solving of Fourier series of periodic function 2 pi. At the first chapter of the Fourier series that we have to cover. So before I start our today's session, I would like just to answer some few questions that are going on in your mind. You can ask me a question, you can ask yourself a question, what division we have in Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM? Well, that's a good question. And the answer is, Proverbs chapter 19 verse 18 state that where there is no vision, people perish. If we don't have vision in all people, then we are going to perish. So we are here in order to declare the visions, and you have to believe on it, and let us believe on it and make sure that we achieve it. Here it's a vision. I have an assignment and responsibility to teach all the online undergraduate students on how to extract knowledge, understanding, and wisdom from the classroom instructions in engineering, mathematics, in electrical engineering, telecommunication engineering, electronics engineering, and combine it with knowledge, understanding, and wisdom that we are going to teach them to extract it from the Word of God written in the Holy Bible in order to solve real-life problems. So the main objective of OPITO in abbreviations, which are abbreviations of Online Undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM, is to teach our students to think differently, to think outside of the box. But remember that we cannot jump into that vision directly. We know that our students are being stressed out with different modules or different courses. Different modules or different courses actually that they are using to pursue during the year undergraduate studies. So the first responsibility that we have is to eliminate such kind of fear or such kind of struggle on understanding higher engineering mathematics and higher scientific mathematics. Then afterward, we are going now to teach you, because we know your mind will be free, because in order for you to think outside the box and especially to think on how to solve real life problems, actually that your mind should be well focused and your mind should be well prepared. So the first phase for this program, for this project, is actually to teach you how to master higher engineering and scientific mathematics. Then, as long, because we believe that you'll be a permanent online student in our Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, so we'll be having some other phases of this national and international program. So again, I know that you have experience, especially for the Tanzanian national students who are studying in Tanzania in different institutions or different colleges or universities. I know that you have experience on how to learn physically, offline. Then now comes the questions, how can you ask questions in this program or in this session? Well, the answer of your question is, in regular classes, you used to ask the questions orally, and also a teacher can answer your questions by accompanying the oral and writing sometimes, or by using the oral. In this platform at this time, we really recommend all our students to interact with us, to ask questions, submit homework, give us feedback, to share with us testimonies, and even just to submit the homework, right? Submit the homework and establishing the online group. The online groups through the comment sections on your right hand side. Means for you it is on your left hand side, but for me it's on my right hand side. So in the comment section of every lecture, this is not a session, excuse me, let me do just minor correction. We are in lecture 5, not section 5, excuse me. So this is lecture 5. Okay, this is lecture 5. We are done with lecture 4. So use the comment section to ask questions. Again, if it's your first time, you're warmly welcome. We love new students. We ask you to register yourself permanently and receive notification whenever we publish a new video, because in every week, at least in a week, we can publish 2 to 3 videos. So we want you to be the first students to be notified, to be given notification once we publish a new video. So make sure you click the buttons of subscribe in order for you to register yourself and enjoy the beauty of higher engineering and scientific mathematics. So are you ready, my dear students, to go into today's session, today's lecture, which is lecture 5? Are you ready to continue on learning how to solve problems of Fourier series of periodic function of 2π? So if the answer is yes, take your scientific calculator, take your exercise book, take your pen, and take your fresh mind. Let us go into the business. Just to start this quick review of what we have taught you, actual lecture 4, lecture 5, and lecture 6 All of these are depending lecture, what we taught you from lecture 1 to lecture 3. Alright? So, whenever we are discussing about Fourier series, this is key points. So first of all, we have series Fourier coefficient. Let me remind you about that. Series Fourier coefficients. Series Fourier coefficients. And these Fourier coefficients of periodic function of period of 2 pi, because there will be the form of these Fourier coefficients will be changing as well. We switch also, or we change also the period or the type of the function. So the first one, we used to say that A naught, it is 1 over 2 pi, integral from negative pi to pi, then our function, our periodic function ffx dx. Then we have another Fourier coefficient an, which is 1 over pi. Then we have from negative pi to pi. Then we have ffx cosine of nx dx. Then we have a third Fourier coefficient, which is 1 over pi. Then integral from negative pi to pi. Then ffx sine of nx dx. Then we have the general formula of Fourier series. This we call the general formula of Fourier series. So the general formula of Fourier series is this, that ffx is equal to a naught plus, then we have sigma notation, n is equal to 1, n is equal to infinity, and then here we have a n, we have cos of nx plus what? Plus bn, then sine of nx, like this. Okay, so this is the general Fourier series formula, not the general Fourier series formula. Okay, so in previous session we taught you how to solve example 3 and example 4. Right? So today we are going to teach you how we can solve example 5 and example 6. Remember that we have also a responsibility to make sure that in all our sessions we'll be solving questions from the past papers in different institutions about the Fourier series, especially all the institutions which are under the NACTE. NACTE is abbreviations of National Council for Technical Education. Are you an engineer? Do you love engineering? If the answer is yes, then let us enjoy the beauty of higher engineering and scientific mathematics. Tell your neighbor, higher engineering and higher scientific mathematics, higher engineering mathematics and higher scientific mathematics is beautiful. So let us go, ladies and gentlemen, let us go into example 5. So example 5, you have to refer DIT final exam, section A, question 1F, question 1F, and this is concept. Concept. The free of what it was a free of fine exam. F is abbreviations of fine exam. So this question has been asked in Dar es Salaam Institute of Technology, the fine exams of Dar es Salaam Institute of Technology of 2018, section A, question 1F. And the question itself also, it's concept. You have a certain concept that you have to be careful, otherwise that you may be confused. So the question states that if the Fourier coefficient, remember that if it's your first time, you may click the buttons of subscribe for you to be registered into our fantastic community of online. So if the Fourier coefficient Bn is equal to negative 2 over n. Then we have negative 1 power n. Write the Fourier series. Write the Fourier series. Write the Fourier series, and this is, once you write the Fourier series for the given Fourier coefficient, you will be awarded 3 marks. So remember that we are using the method, we call it active learning system. Say active learning system. Do you know how active learning system work? Well, so the active learning system, the student is the center of learning. So once you've copied the question on your exercise book, once you have finished it to copy the question, which is the example 5 on your exercise book, you may take your rough paper, pause the video, and then try to solve this question yourself by using the concept I taught you in lecture 1 of Fourier series, lecture 2 of Fourier series, lecture 3 of Fourier series, lecture 4 of Fourier series, and even by using those formulas of Fourier coefficient and general formula of Fourier series. Alright? So you can try. Once you are done, then you click the buttons of play to check the solution and correct yourself, because in our online program, you have to discipline yourself in learning system, because mathematics demand students to do much of the practice on solve. If the Fourier coefficient Bn is equal to negative 2 over n, then times negative 1 power n, write the Fourier series. Write the Fourier series. So here it's solution. If the Fourier coefficient Bn is equal to negative 2 over n, then negative 1 power n, write the Fourier series. Well, so solution. So for this question, we've been given a general formula of Fourier, of one of the Fourier coefficient. Okay? So one of the Fourier coefficient. So we say that the first step, okay, first step, and then we've been asked to write the Fourier series. The first step, we ask you to recall the general formula of Fourier series. The general formula of Fourier series. Okay, the general formula of Fourier series. General formula of Fourier series. How does it state? So you've been asked the f of x is equal to a naught plus, then sigma notation from n is equal to 1 to infinity. And here we have a Fourier coefficient of an, then cosine of nx plus Fourier coefficient bn, sine of nx. Okay. So according to the question, we say that we go into the, okay, so it means that according to the general Fourier series, we need to know Fourier coefficient a naught, Fourier coefficient an, and Fourier coefficient bn. But for this question, we've been given only one Fourier coefficient. So to simplify life, or to simplify our computation, we go into the second stage. So the second stage, we say that assume a naught is equal to 0 and an is equal to 0. Is equal to 0 because they are not given in example 5. So for that case now, our general Fourier series will be in this form. F of x is equal to what? Is equal to sigma notation from n is equal to 1 to infinity. Then here we have bn sine of what? Of nx. Sine of nx. So suppose that this to be equation 1, and now this to be equation 2. This to be equation 2. This to be equation 2. This to be what? Equation 2. So if that's the case, we go into the third step. So this step, we say that substitute equation, substitute Bn into equation 2 above. So we have f of x is equal to what? Sigma notation from n is equal to 1 to infinity. Bn is what? What the value of Bn? Bn is negative 2 over n. And then here we have what? We have negative 1 power n. So we have what? Sine of what? Sine of nx. So from there, we've been asked to find the Fourier series. When you say you have to find the Fourier series, in most cases, even this one also is the Fourier series, but the Fourier series expressed in terms of sigma notation. So this is the shorthand of what the Fourier series. But in most cases, whenever we asked to find the Fourier series, we have to find the extended Fourier series. So we say extended Fourier series, the Fourier series that contain the first term, second term, third term, fourth term, and dash, means, and etc., etc., etc. So here we are in the fourth stage. Okay, so this will make equation 3. This will make equation 3. So the first step, we say that substitute. So we say that substitute. So let us substitute n is equal to 1. Substitute n is equal to 1 into equation 3 above. Okay? Into equation 3 above. So when you substitute, it means we get what? So in substitute n is equal to 1, we just let us ignore the sigma notation from there. So it means that we are going to have negative 2 over what? Over n, which is 1, times negative 1 power n, where n is 1. Okay? And then here we have what? We have sine of what? Sine of 1 times x, which is sine of x. Okay? Then, if that's the case, we say that that's why in simple way, because this is the value of Bn, we may say that B1 is equal to negative 2 over 1, which is equal to negative 2. Then negative 1 power 1 is equal to negative 1. So the answer is 2. That's why you say that B1 it's what? It's 2. In other words. But it is 2 when also sine of nx is equal to what? Sine of nx, it is sine of 14, sine of x. Alright. Okay. So then we say that we go into the fifth step. Fifth step, we say that substitute n is equal to 2. Into what? Into equation 3 above. So from there, it means we get B2 when n is equal to what? So B2, remember that it's when n is equal to 2. So it is negative 2 over 2, negative 1 power 2. So negative 2 over 2, it is negative 1. Then negative 1 squared, it is positive 1. So this will make negative 1. So it means B2 is equal to negative 1. So then here it is, it means sixth step. So the sixth step, we say that let us substitute. Let us substitute n is equal to 3 into equation 3 above. So this will give us B3. Here it is negative 2 over 3. We have negative 1 power 3.
So this will make negative 2 over 3. Maybe lastly, let us find the fourth step. So the second step, substituted. So substitute the value of n when n is equal to 4 into equation 3. So here it is b4. So b4 is equal to negative 2 over 4, negative 1, comma 4. This is equal to negative 4 over 2, 4, negative 2 over 4 is negative 1 over 2, and then negative 1 power 4 is positive 1. This is negative 1 over 2. Okay, so the eighth step, we say that let us write the Fourier series. Let us write the Fourier series in expanded form. In expanded form. So you may continue up to n is equal to 5, n is equal to 6, up to n is equal to infinity. So in extended form, we say that f of x is equal to b1. What the value of b1? b1 is positive 2. So positive 2, but here we have also sine x. So b1 is when n is equal to 1. So sine x, nx, when n is equal to 1, to make sine what? Sine x. Then here we go into b2. b2, which value is negative 1, so we have minus. Then the angle will be what? When n is equal to 2, we have sine of 2x. So minus sine of 2x. Then here it is. We go for the next term, which is b3. So it is what? Negative 2 over 3. So this is negative 2 over 3 sine, what the value of angle? T3x, because n T3. Then we go into b4, where we have what? Negative 1 over 2. Then we have sine of what? Sine of nx. So it is sine of 4x plus dash 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 dash, or minus dash 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 dash. Okay? So this is our Fourier series. So the question asked us to write a Fourier series. Okay? So therefore, conclude therefore the Fourier series is f of x is equal to 2 sine of x minus sine of 40 of 2x. Then minus 2 over 3 sine of 3x minus 1 over 2 sine of 4x plus dash dash dash. Okay, that's all about example 5. So now here's my question. Did you understand how to solve example 5? The answer might be yes or no. Whether the answer is yes or no, let us know in the comment section below of this video. And I want to tell you that we are going through, or we are reading your comment section, and try our level best to answer your questions as we can, because we love our sessions or our lectures to be interactive in order for many students to enjoy the beauty of higher engineering mathematics and higher scientific mathematics. Did you enjoy it? Do you love higher engineering mathematics? Do you love higher scientific mathematics? Let me know in the comment section below. So let me present to you this was some correction. It was question 1E Roman 2. It was question 1. It was question 1 E Roman 2. Question 1E Roman 2. Okay. So then, ladies and gentlemen, right now let me go into question 1F. Okay, so here the question. So example 6 is also a concept. You have to be careful, especially for this, because Braille is going to teach you something new. So the question asks you to determine the Fourier series of the function represented by the following graph. Represented by the following graph. So we'll be given a graph which has exclusive small cycles, not inclusive. So let me sketch it. It's a graph of a certain periodic function. So here it's a graph of periodic function. So graph periodic function. So here we have x coordinate, and then we have another x coordinate, we have another x coordinate, we have another x coordinate. This is positive 4. This is negative 4. This is x. And this is f of x. And here it is 0. This is pi. This is 2 pi. This is 3 pi. And this is 4 pi. This is negative pi. Then we have again down there. Okay, so this is the given figure. The question said determine the Fourier series of the function presented by the following graph. So today we are not given the function, we'll be given a graph. And they've been asked to determine the Fourier series. So remember that we are using the active learning system. You can pause the video and try to solve the question yourself on the piece of your rough paper. Once you are done, then you can check the solution to correct your try. Don't worry to try in higher engineering mathematics and also in higher scientific mathematics, because trying really makes you to enjoy and understand higher engineering scientific mathematics. Well, so now let us go into the solution. So I think that you can pause the video and try to solve example 6 on the piece of paper, and then once you are done, let us do correction. Are you ready? So let us do correction. Solution. So we'll be given a graph, and this is a periodic function graph. Why is periodic? Because you see that when time t0, the value of the function is 4. And this 0, its interval after pi. It means that within 180 degrees, here's a function. And within 180 to 360, the graph is this one. Similarly here, similarly here. So it means that the nature of the graph repeats itself after a certain interval. Okay. So if that's the case, we're not given the function today, we'll be given a graph. You know the concept there? The secret is we have to use the given graph to find the function first, because we cannot find a Fourier series without having the function. And also we cannot find a Fourier coefficient without having the function. The function might be a step function, or it might be a trigonometrical function, like in lecture 60 we'll teach about trigonometrical function, or it might be it can be exponential function. So we have so many cases and so many types of the function that you may be given to write or to find the Fourier series. So the first step here, we say that formulate the function f of x from the given graph. So how do we formulate? We have the function which is called f of x is equal to it. So this is let's cut it back like this one. And then we have our function which is 4. Then the interval is from 0 less than x less than pi. Wow. That's why we have these signs, symbols of what? Exclusive. It means that the symbol might be less than or greater than. If it is a full circle like this, then now the symbol will be greater than or equal, or less than or equal. Okay? So this function gives us this graph, and etc., etc., etc. Again, we have another part of the graph, the second part of the graph. So the second part of the graph, the value of the function or the value of y is -4, but what the interval is from pi less than x less than 2 pi. So here it's a composite function. It's a composite function. So because we have our composite function, now we can find the Fourier coefficient, and once we get all the 3 Fourier coefficients, we may use the general Fourier series formula to write the Fourier series. So now the second step is this. So it means that let us find the value of A0. And then the general formula of A0 is this. Here it is 1 over 2 pi, integral from negative pi to pi, f of x dx. Okay, so to find A0, this is 1 over 2 pi. Then from what? From 0 to pi. Then when f of x is 4 dx. Then we have integral from what? From pi to 2 pi. And our function is -4 dx. So 4 is common, we take it out. So we have 4 over 2 pi then integral from 0 to pi of d of x, and minus integral from pi to pi of d of x. I told you in previous session, especially lecture 2 and lecture 3, that the integral of dx it's x, or is equal to integral of x power 0 dx. So use the power rule to integrate that function. So here it is a naught. So 4 over 2 is 2 over pi. Here it is x. Here we have 0 to pi minus x over 1 from pi to pi. So this is a naught. It is 2 over pi. So substitute pi in x, it is pi minus 0. Minus. Here it is what? Substitute 2 pi, it is 2 pi minus pi. Here it is what? A naught is equal to 2 over pi. So here it is pi minus 2 pi plus pi. So pi plus pi, it is 2 pi minus 2 pi, it is 0. 0 times 2 pi, it is 0. So simply the first Fourier coefficient is 0. Check your trial. Did you succeed to get it? If you have got a naught is equal to 0, congratulations. If you missed it, don't worry. Try over and over and watch this video several times until this concept has been written in your mind. Okay, so here the third step. The third step, let us now find an. So from the general form of an, so 1 over pi integral from negative pi to pi of f of x cosine of nx dx. This is the general formula. Calling the given function, here we have 1 over pi, open the curly bracket, then you have integral from 0 to pi of f of x. What's our f of x? This is 4 cosine of nx dx plus integral from pi to 2 pi. We have f of x, which is negative 4 cosine of nx dx. So 4 is common. 4 is common, so you have 4 over pi. And then, so you have 4 is common, you have 4 over pi, we take it out. Then you have integral from 0 to pi. This is cosine of nx dx plus what? Integral, then from what? From pi to 2 pi. This will be minus what? Cosine of nx dx. Okay, so I believe you have tried to find an. So once we get the value of an, you may compare it with what you have found in your trial. So here we have a responsibility of interpreting cos of nx and cos of nx. I told you, whenever you interpret cos of nx, the answer is sine of nx over n. So this is an is equal to what? Is equal to 4 over pi. So if you integrate the first trigonometrical function, the answer is sine of nx over n from 0 to pi. Then we have what? Minus what? Minus, here it is what? We have sine of nx over n. Then we have pi to 2 pi. So we have an. This is 4 over n pi. And here it is what? Sine, when x is equal to pi, n pi, minus sine of 0 times n is 0. Then here we have what? Sine of 2 pi n minus what? Sine of n pi. So let us simplify. We have an is equal to it. An is 4 over n pi. And here we have what? Sine of n pi minus sine of 0 to 0. Then we have minus. Here we have sine of what? Sine of 2 n pi. So let us open this bracket. So this will be minus, and here it will be plus. Plus what? Sine of n pi. So an, so let us close the curly bracket. So an is equal to 4 over n pi. Collect the similar terms. This term and this term are similar. Positive, positive. So we have 2 sine of n pi minus sine of 2 n pi. So you may say that this is the general form of an, but you have to check because sometimes they cancel each other. So let us try, for example, to find for odd an, let's say, means let us try n is equal to 1. To give us the property for n is equal to 1, n is equal to 3, n is equal to 5, n is equal to 7, n is equal to 9, n is equal to 11, etc., etc. So it means that a1 to be 4 over pi. So we have 2 sine of what? Of pi minus sine of 2 pi. So sine of pi means sine of 180 to 0 and sine of 360 to 0. So a1, all the odd terms will be 0. So even if you find a3 on your time to 0, a5 on your time to 0. Then let us check for even term of an. So for even, just we take a sample of n is equal to 2. Substitute there. Okay? If you have any question, don't hesitate to ask in the comment section of this. So when n is equal to 2, we have what? So a2 is equal to it. Is equal to 4 over 2 pi. So you have what? You have twice sine of what? Of n pi. Sine of n pi when n is equal to 2. So sine of 2 pi minus sine of 2 pi times 2, which is equal to 4 pi. So a2 for this case, sine of 360 is 0. And sine of what? 540 is also 0. So because it's 0, so 0 minus 0 times 4 over 2 pi is 0. So even find a4 is 0. you can find a 6 to 0. So for that case, you may find that A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, etc. are 0. For that case, we say that the value of Fourier coefficient An is 0. Wonderful. Very interesting. Wow. We are about to end this session. Okay. And then here it is. So we are in what? So let us get into the forces tape. No, this is the forces tape. Here it is the forces tape. Forces tape. This is another step. So this is the fuses tape. So the fuses tape, let us find the Fourier coefficient Bn. Okay? Find the Fourier coefficient of Bn. We have to recall its general formula first. So Bn is equal to 1 over pi. Then integral from negative pi to pi of f of x sine of nx dx. So Bn is 1 over pi. Put the function that you found. Integral from 0 to pi for sine of nx dx plus pi 2 pi minus 4 sine of nx dx. 4 is common, we can take it out of the bracket. We have 4 over pi. So inside we have to integrate from 0 to pi the function sine nx dx. Remember that whenever an is 0, bear in mind that bn is not 0. Okay? And whenever that bn is 0, an should not be 0. Okay, so here we have minus, so negative what? Integral from pi to 2 pi. Then we have sine of nx dx. So I've told you that whenever we integrate positive sign, we get negative sign. And whenever we integrate negative sign, we get positive sign. So even this one, we can still treat it here positive, and this is negative. So now, when we integrate this function, these two functions, we get bn is equal to what? Is equal to 4 over pi, open the curly bracket. Then if you integrate sine of nx dx, sign here is positive, so we'll get negative cosine. So negative cosine of nx over n. But our limits are from 0 to what? To pi. Then plus, when we integrate negative sine of nx dx, then we get positive cosine. Positive cosine of nx over n. From pi to 2 pi. Okay. So then we take n out. Bn is equal to 4 over n pi. Take n out. Then remain. We have negative cosine of nx. Negative cosine of nx from 0 to pi plus or minus, plus what? Positive cosine nx from pi to pi. So here it is Bn is equal to 4 over n pi. Then this is negative cosine of pi n minus plus cosine of 0. Minus means negative. So remember that here it was minus negative cosine of 0. So let me just put this to avoid confusion. Plus what? Substitute 2 pi in n, in x, in the value of x. Here we substituted x by pi, and then here we substituted x by 0. So 0 times n is 0. Then here we substitute 2 pi in x. So it will be cosine of what? Cosine of 2 pi n minus what? Cosine of, substitute x or substitute x by pi. So sine of what? Of pi. Then we have our curly bracket. So as I told you this technique, whenever you find a n, it's 0. Then make sure that n cannot be 0. And otherwise you have made a mistake. Whenever you find that a n is not equal to 0, it's not a guarantee that the n will be 0. It might be 0 or not 0. So one thing which I want to tell all undergraduate students, all NTA level 7 students, all the first year students, if you are doing this module in first year, right? Because the name of the module is called the calculus, right? So one thing that I want to tell you that, my dear students, don't claim higher engineering mathematics and higher scientific mathematics. This is mathematics for engineers, and this is mathematics for scientists also. You know what the means of engineering? It's the purposive use of of science. So if that's the case, here we have 4 over n pi. So here we have negative cosine of pi n. Here you have negatives. Negative is cosine of 0. Use your scientific calculator. It's positive 1. Then plus what? Then plus cosine of 2 pi n. This one. So then minus what? Here it is. I forgot n because I substituted x by pi. So it will be pi n. So it will be minus what? Cosine of n pi. So Bn simply negative cosine pi n and negative cosine n pi are the same term, so we can add them. So it will be, so it means here we have 4 over n pi, and then we have what? Negative 2 cosine of n pi. We add like terms, and then plus 1, which is not similar, it's any term, and then plus what? Cosine of 2 pi n. And here we have our curly bracket. Okay? So this is our Bn. If you are writing the Fourier series in its sigma notation, then this will be the right answer, or means that this will be the term that we have to substitute in Fourier series. So We may either find B1, B2, B3, or B4, and then substitute in Fourier series. But remember that whenever value of n is, so it means we may do this one, because we know that this is Bn. Okay? Okay, so this is Bn. So we go into the sixth stage, about to finish this session. So say that when n is equal to 1, so B1. So B1, here we have 4 over pi. And then here we have negative 2 cosine of pi, which is cosine of 180, then plus 1 plus cosine of 2 pi, which is 360. And also in terms of sine, the part of sine will be also sine of nx, because here we have sine of nx, it will be sine of x. So B1 for this case will be 4 over pi. So you have negative 2 cosine of pi, it is negative 1, so it will be positive 2 plus 1, then plus what? Cos of 2 pi, it's 1. So, but the end which is sine of x. So it will be what? 2 plus 1 is 8. So B1 is equal to 8 over pi, and our sine is x. Okay, so we are writing the Fourier series of the conceptual question. So I may leave now until we solve this example 6 to understand the concept of Fourier series. 7th step. So the 7th step, we say that when n is equal to 2, here we are going to have B2. So B2, it is what? It is 4 over 2 pi, then negative cos of 2 pi plus 1 plus cosine of 4 pi. So here it is 2 over pi. Cosine of 2 pi, it is cosine of 360. So here you have negative 2 plus 1. Cos of 4 pi. So 4 pi, it is cosine of 560, which is still 1. Which is 1, because 360, it's 720. Because 2 pi is 360. Multiply by 2, you get 0.27. So the cosine of 720 is 1. Because cosine of 2 pi is equal to cosine of 4 pi is equal to cosine of 6 plus 6 pi is equal to cosine of 8 pi is equal to cosine of 10 pi is equal to cosine of 12 pi is equal to cosine of 14 pi is equal to cosine of 14 pi is equal to cosine of 16 pi, etc., etc. So for this case, we have negative 2 plus 1 is equal to 0. So B2 it is 0. And this is for all the even terms. So we go into the A step. So the A step, we say that when n is equal to 3. So when n is equal to 3, we have what? B3 is equal to what? Is equal to 4 over 3 pi negative cosine of n pi. What is pi n? 3 pi means 270 plus 1 plus what? Cosine of 6 pi. Remember that cosine of 6 pi is equal to cosine of 3 pi. It is cosine of 270, it's negative 1. It's negative 1. And this one also it's negative cosine of 300, cosine of 106. So let me use your scientific calculator. So you have 3 times 180. If you don't have any calculator, you may order in our online shop. So cosine of 270 is 0. Then you have 60 times 180. So cosine of 1080. It's 1. So cosine of, cosine of 300. No, this is 3 times 180, which is 520. So cosine of 520 3 times 180, multiplied by 2, okay, so divided by 2, so find the cosine of the answer, it's negative 1. So the 3 is equal to 4 over 3 pi, negative 2, negative 1, and I forgot. So for here, if you're writing sine, when n is equal to 2, it will be sine of 2x. So negative 2 cosine of negative 1 plus 1 plus positive 1. 6 times 180. Here it is cosine. So it's positive 1. So negative 2 times negative 1 is positive 2 plus 1 is 4. 4 times 4, it's 16. So this is 16 over 3 pi. For the sine function to be sine of 3x. So now it's time for the homework 5. Okay, so use the value of bn, use the value of bn to find b4, b5, b6, and b7. That's your homework. So I help you to find b1, b2, b3. So for you, 4, 5, 6, and 7, which will make you to practice on how to find the coefficient terms, the terms of coefficient in any Fourier series function. So that was this is 8th step, so we go into the 9th step. The 9th step, we say that recall Fourier general Fourier series formula, or general formula of Fourier series. So the general formula of Fourier series, remember that the module name is called the calculus. Module name is called the calculus. It's called what? Calculus. So Fourier series is one of the topic of calculus. So the Fourier series, the general formula of Fourier series is f of x is equal to a naught. Then here it is summation, n is equal to 1 to infinity. Here it is an cosine of nx plus bn sine of nx. So remember that a naught is equal to 0, and also an is equal to 0. But good news, bn is not equal to 0. So for that case, now I say f of x is equal to summation from n is equal to 1 to infinity, bn sine of nx. So now to write the Fourier series, therefore the Fourier series f of x is equal to b1, or the value of b1 is 8 over pi. Then its function is sine of x when n is equal to 1. Then plus what? b2, or the value of b2 is 0 sine of 2x. Then plus value of what? Of b3. b3 is what? 16 over pi, then sine of 3x. So once you find b4, you write the first term, b5, you write the first term, b6, you write the sixth term, b7, write the seventh term. So for me here, I'll just have this, and this is the solution for the given question. It's really disappointing, according to the marks, that you've been looking for 4 marks, but that's how high engineering mathematics and the high scientific mathematics used to be, because we're teaching you on how to deal with complex problems. So this is the response. Okay, so here are the questions I have to you. Did you understand the solution of example, or the word concept and solutions of example 6? The answer might be yes or no. Whether your answer is yes or no, let us know in the comment section below this video. My dear students, I would like to say this is the end of lecture 5, which has been titled Problem Solving of Fourier Series of Periodic Function to pi. I ask you to join me in lecture 6, where also I will teach you now conceptual questions about Fourier series, and where I will teach you how you can find a Fourier series of trigonometrical function, because it's a little bit challenge. Trigonometrical functions has a little bit challenge of using factor formula sometimes, or using some different techniques, because especially when you'll be finding the Fourier coefficient an and bm. So the entire lecture 16, I'll be teaching you only one question, how you can solve and how you can find Fourier series of the trigonometrical function. We have also another challenging function, which is exponential function. And the main challenge for exponential function means that whenever you integrate exponential function, you will get the same function. So you can integrate it over and over. Right? That's the challenge. But don't worry, stay tuned. I will teach you, because this is still the first chapter of Fourier series, while the next chapter will be called the Fourier series of non-periodic function, and then the next chapter will be called the Fourier series of odd and even function and half range. Then the next chapter will teach about Fourier function over any range, and the next chapter will teach about the complex exponential Fourier series. So you still have 4 remaining chapters. So this is still just one chapter. So you should not worry, should not panic, and should not cram. We're really insisting our online students that try your level best to watch this video several times and understand it, because questions in the exam might be a little bit tricky and different from the one that we are teaching you. Why? Because they want to test your level of understanding. Remember that understanding, it's a home of our online undergraduate polytechnic Institute of Tanzania in square bracket Olenjolai. So if you have any question about lecture 5, don't hesitate to ask in the comment section. And if you have been a new student but you have never registered yourself, or you have been a regular student, we insist you to register yourself free into our official YouTube channel, where you can receive and learn the beauty of higher engineering and scientific mathematics by using the syllabus of United Republic of Tanzania. But higher engineering mathematics and higher scientific mathematics, these are universal contents. So every student in the university has to learn this content. So we ask you to subscribe, and in case you want to access all the sessions, all the lectures about Fourier series, then make sure that you go into our official channel and then just click the button that called playlisting and find the playlist written Fourier series, where you find the collection, the systematic collections of Fourier series function or Fourier series, right? So before we end this session, we will invite you, in case you feel from your heart you would like it to be a part of this program, or you would like to offer your feeling thanksgiving after receiving this content without any payment, by offering your feeling thanksgiving through this program. So you may offer a living card, your feeling thanksgiving for this program by using two methods. The first method, you may use this telephone number 0759745331. But again, in case that you have exceptional issues, or you have challenges and whatever that need graphics or need picture communications, you may use also this number for WhatsApp, and I can try my level best to answer or to meet your requirement, right? So you may use this method. In case you want to do the bank transaction, you would recommend just read the description below and see the bank account and the bank number. So remember that you are feeling thanksgiving, or you are offering your free willings, it means should come from your heart, will be used to pay for the running cost, because you have a vision of recording more than 800 videos that will teach about high engineering and scientific mathematics to any undergraduate students in any institutions, college or university in Tanzania and worldwide. So this is actual lifetime program and lifetime project. So in case you feel you like to be a part of, or you like just to see the progress of this work, don't hesitate to offer your feeling thanksgiving, because we used it to pay for the running cost of this project to be sustainable and to be accessible to present and future generation. So have you understood Fourier series? If the answer is yes, let us know in the comment section. Before we end this session, because we invited God at the beginning, let us give Him thanks for the great thing that He has done in this session. Until today, you have understood the beauty of Fourier series, on solving, especially on solving problems, graphical problems, on solving problems of finding the Fourier coefficient, Fourier series, etc., etc., etc. You are allowed to share these contents to any students that in any institutions and anywhere, because that's the power of the online contents. You may access this content anywhere and at any time. So may God bless you. Let us have our Thanksgiving prayer before we end this session. Our Father who is in heaven, we come before your presence. We say thank you, because you have been a teacher of lecture 5 that titled as Problem Solving of Fourier Series of Periodic Function to Pi. We give you all the glory for how you have taught your online student, and we give you all the glory for the question that they are going to ask you through me. Father, I thank you for the understanding, knowledge, and comprehensions and wisdom that you have given me to feed your body, to feed your children. Father, I thank you for all of these online students who are taking advantage of this content now and for the rest of the year life. Be with them at this time, and be with them when they will take these contents, and be with them, Father, to glorify your name wherever they go. In Jesus' name, amen.
So this is the Olenjolai who does not know everything about calculus, and I don't know everything about the Fourier series. I just know small portions of it, but I have a responsibility to teach others. So stay tuned, keep enjoying the beauty of higher engineering and scientific mathematics. Please leave the comment below in order to communicate, and invite your friends in lecture 6 to enjoy the beauty of the beauty of Fourier series in calculus. So may God bless you and keep you until we meet in lecture 6.